in the intervals of minus and plus 2.5 mm, or the maximum aggregate size. So not 2.5 mm, 25 mm. So if your maximum aggregate size is 25 mm, which is 3/4, okay. So that's the one we use as minus plus. So what do I mean by that? So if you get a slump of if the specified slump is 200, that I should have a slump of 200. Okay, so 200 minus 25, that will be 175, acceptable. So again, so if another truck comes by, we measure the truck, the slump of it, and it's 225, also acceptable. All right, 230 is not acceptable, 170 is not acceptable. Okay, it's less than it should be, and that one is more than it should be. So 230 is more than it should be, and 170 is less than what should be. Okay, our target is 200, so it's plus minus 25 mm, which is the maximum aggregate size. So what about if the maximum aggregate size is bigger? Yes, it follows the same. Okay, so if it's 37, it's 37. And why is that? Because the aggregate actually can be standing in a vertical way or horizontal way. So if it's vertical, okay, we'll read 25 mm higher. And if it's horizontal, I mean, it went down, we'll read it minus. And that's about it. What about zero and true slumps? True slumps, this is what I have seen a lot here in Nigeria. And the concrete, if it talks seriously, it will have a lot of complaints. The exposed aggregates, the honeycombs, the problems. You see, the lumps. I mean, the unmixed, not the concrete will be not mixed in a good way. You'll have a lot of lumps in your concrete. And what's the meaning of lumps? Lumps is when you mix your concrete, okay, with water and admixture, and you move everything, you will have just like balls. So when you break that one, okay, you'll find that your sand or your cement inside actually has not, the water or the admixture did not reach it. It's just dry. Okay, that's dry, and it happens often in the high grades of concrete, like C50 or C40, C45, C50. Okay, so we should be careful about that. A true slump is very, very bad in placing, very bad in transporting, and definitely. I mean, when you want to place it in the foundation or for instance, any element of concrete, a beam or a column, okay, you have to use a lot of vibration. And also, again, this will go into the hand of the worker at site. Experienced workers will be appreciated. However, it was not. It will vibrate the concrete to the extent of segregation, and again, the structure is jeopardized. Your durability factor is jeopardized. Now, zero slump concrete, that's a type of slump that we use it as a mixed design for airbornes or for paving concrete or for concretes for casted. I mean, where we make roads, and actually we call it zero concrete or zero slump concrete. However, it's 20 mm. The allowed thing about it is the allowed interval for the slump is 20 mm. I think I spent a lot of time on this. Okay, water cement ratio of concrete, the quality, of course, and fine aggregate, their shape, moisture content, texture and grading, the use of plasticizers with plasticizer admixture, and the subsequent of their mixing, the void ratio of concrete and air content of concrete, the time of test after mixing of concrete. That are the factors that influence concrete slump value. Well, yes. Okay, so let me just break it down a little because this is very important. the quality of coarse and fine aggregate, their shape, moisture content, texture, and grading. So fine aggregate, the surface area for it is more than the surface area of the coarse aggregate. And when we talk about surface area, means we need more water, natural. So the more the fine aggregate there is, the more water that you need. So your slump readings, okay, has to do a lot of how much fine you have put in your mix design. Their shape, yes. Now, for instance, let's take the two types of aggregate. If you take the limestone, okay, aggregate, you see smooth on the surface, while the gabbro, it's textured, all right. And yes, this also affect how much water do you need, because the smooth surface is not like the textured one. Okay, moisture content. Some of these aggregates, and let me stay with the limestone and the gabbro. Limestone will actually absorb water, while gabbro it's less absorbent to the water, which means you'll have more water to mix. Okay, so again, how much water your ingredients as gravel, and I mean sand, stone, you say, or aggregate, will suck will take it from your mix design. Okay, your slump also will be affected. However, that's why we have a rule which says SSD, which called surface saturated dryness. I'll repeat it again. SSD, surface saturated dryness. Okay, which means your component has to have their own moisture content. Yeah, they don't have, they don't look like wet, but they have enough water in itself, so it will not take the water from my mix design when I add water, right? So, but again, this also will affect the slump. Okay, something else that will affect the slump, and actually it's not mentioned here, and it has to do with your sieving. So you have to be careful about your passing 30. Okay, the passing 30, or actually we call it the very, very fine aggregate, or fine, yes, the very fine ones. Okay, which is a form of clay actually. Okay, now the use of plasticizer, super plasticizer admixture, and the subsequent of their mixing. Okay, we are going to talk about admixtures in the coming few slides, so I'll leave this one. The void ratio of concrete and air content. I'll talk about this one now. Air is very important to the concrete. All right. So why air is important to the concrete? Now, the entrapped air, we hate it because it forms big bubbles. You see, something with like 2 mm, 3 mm in diameter, which actually promotes a lot of gaps inside my concrete, and it will make my concrete more permeable to water, and definitely more permeable means my corrosion or the probabilities of my steel gets corroded is higher than less voids in my concrete, isn't it? All right. So what is the type of air that we really like? The type of air that we really like and encourage it to be added in our concretes is we call entrained air, and you can go up to 12%. Now we said the ideal mix is 6%, but you can go to 12%. So what exactly air will enhance my concrete durability with? Now, the entrained air is in the size of 10 to 100 microns, 10 to 100 microns. Sometimes it can go up to 150 microns. It's acceptable. Microns, each 1,000 microns equals 1 mm. Okay, each 1,000 microns equal 1 mm. So when I say 10 microns to 150 microns, well, is a very, very, very small bubbles inside my concrete. Okay, so what it does, what it does basically, it will entrap and disrupt the capillary system of the concrete. So basically, when water is going in, and trying to penetrate the surface of concrete. It will go inside this void and or this bubble, and there's no place else for it to go. All right. So that's one. Second of all, when you add air to your concrete mixture, your concrete becomes lighter. So if, for instance, if your concrete is 2.4 as density, it becomes now, for instance, 2.2 or 2.1, or in some cases we can even go to 600 kilograms. Imagine each ton of each one meter cube of concrete, it can be 2.4 or 2,400 kilograms, okay, and can be reduced to 600 kilograms of concrete. I'm not saying that that's a different type of concreting. We call it lightweight concrete, but I mean we can use air even to achieve that. All right, and each concrete has its own type of use. All right, there's no bad concrete. Okay. Okay. What else? What air will do for me? Freeze thaw cycles. Freeze thaw, it will enhance it dramatically, which means again it will fall into the durability factor of your concrete, contraction and expansion. Okay, contraction and expansion of your concrete element, and definitely air training will help a lot in it. What else? So in places of I mean Nigeria, there's not that much cold. Okay, then not that much icing, or maybe there is I heard there is a state that there'll be some kind of I mean of dropped temperatures in there, and maybe this type of concrete is really required there, because when water gets freezed, well, the size of it increases, and if the water was inside the concrete and freezes, you know what's going to happen. All right. So for us to release the stresses exerted by the increased size of the water inside the concrete, these small bubbles will relieve the concrete. Okay, and the excess volume will just go through these bubbles, and yes, it will enhance our durability factor of our concrete dramatically. Okay, the time of test after mixing the concrete. Yeah, well, it's very important that the concrete gets tested within the standard times of limit. I mean, as specified. Okay, I would really recommend for you to read ASTM C4143. Okay, it talks a lot about this, and I'm just gonna pass it. Okay, so that's another ASTM that we should memorize by heart. It's called ASTM C494. You are all engineers. I'm sure that you know all about it, and but I really recommend that you memorize this. This is the Bible of all types of admixture. The Bible. This is the one. Okay. In the ASTM C494, it talks about SNF admixtures. Okay. Only this type of admixtures. And remember, I said it's more than 14 types. Okay, and each type has its own its own job. But in ASTM C494, we have this part which talks about different types of admixtures as a classification. So we have type A. So what's type A? Water reducing admixture. Type B is retarding admixture. Type C, accelerating admixture. Type D, water reducing and retarding admixture. Okay. Type E, water reducing and accelerating admixture. Type F, water reducing high range admixtures. Type G, water reducing high range and retarding admixtures. I look like a robot reading it, right? Does it have any meaning to anybody? Well, it doesn't. Okay, unless we explain it. So type A. So type A is a category by itself. It's called water reducing admixtures, and that was an early technology which has been used in the early 1920s. Okay, and it had the capability of 1 liter of admixture to reduce or to replace the use of 5 liters of water. Okay, so remember type A what it stands for. Type B is a retarding admixture. Its job is just to drug my mix design. It will just postpone the reaction of my cement or reduce it. And there is different methods about it. And I have another slide. Maybe I'll open a few of it just to show you exactly what's the how the admixture works as a mechanism and different types of it. So accelerating admixture is a different type. So remember, A is a type, B is a type, C is another type of admixture. It's a category by itself. A, B, C. All right. I mean, here in the ASTM C494, I'm gonna call them types 1, 2, 3. But in general, they are all one type at the end of the day. All right. I hope not. I'm not mixing anybody up. Now, type C is called accelerating admixtures, and it depends on nitrates or different types of chemicals. So what's type D? Type D, actually, it's the sum of A and B. So if you take type A and mix it with type B, then you will have type D, which is water reducing and retarding admixture. So what's type E? Type E is the mix of A and C. So you have water reducing and accelerating admixture. Okay. So what about type F? It's a new, okay, it's not new now, but I mean in those days, in the 1960s, okay, it has been introduced as a high range water reducing admixture, which can actually compensate the use of 15 to 20 liters of water. Okay, so remember the first one was like 5, some of it actually 5 to 10, but I mean it's around 5 liters per water per 5 liters of water per 1 liter of admixture. Okay, now type F, it can go up to 20. Different types can go to 25. Okay, and for PCs we can reach up to 40. Each liter of admixture will compensate the use of 40 liters of water. Okay, and type G again is the addition or the mix of type F as the higher range water reducing admixture, and D, which is actually the sum of A and B. All right, I hope this is clear, but if you need me to repeat it, just write it down as a question and I will come back to it later on. Okay, water reducers have become as important in concrete that they could be considered the 5th ingredient. All right, uses increased slump, lower the water cement ratio, reduce cement content, advances great workability, increase strength. All right, here actually and all the mixed designs, when I see them, they just try, for instance, the aggregate, the gravel 3/4, the half, the 3/8, sometimes the crushed sand, then they go for the fine aggregate, then they go for the cement, the water. They don't mention the air, definitely, or they forget about it. And then they stress on mentioning the admixture and how much it is. Okay. Now remember, guys, we said the admixture will compensate water. All right. So actually, it's calculated as part of your water. So if your water cement ratio, if you're adding, for instance, 160 liters of water, and you are going, your intention is to add 5 liters of admixture to your mix. So actually, your total water is not 160, it's 165. And this again will interrupt with water cement ratio, as water will be divided on the amount of cement. So actually, you should subtract your amount of admixture from your total water. So if your water is 160 and your admixture is 5, so you have to add 155 plus 5. All right, that's very important also talk about, so that your water cement ratio will not change. And trust me, it really affects it a lot. Okay, now. Yeah, so water reducing admixture, this is what it do. Great workability, well, yes, it does, but again, remember, there's a lot of notes when we talk about workability here. Remember, when your mix is cohesive, means it looks like workable, but it's not pumpable, it's not placeable. Cohesiveness is working against you, stickiness. All right. I mean, if you want to punish somebody, let him just, I mean, uh, what you call it, try to mix it. You know, it's gonna really very, it's really very hard on cohesive mixed designs. All right. So actually, it looks like workable, however, it's not pumpable, and this type of concretes we cannot use. All right. Increase the strength. Yes, add mixtures definitely when you in a direct way. I mean, there is indirect way of for compressive strength to be increased, and direct ways. An admixture has a direct way on your strength of your concrete, and mostly it's positive. Mostly, it's very positive. Now, remember what I have said. What we are discussing here today is durability. All right. So again, strength is a signboard telling you you are going to Abuja. But are you there? No, not yet. When you reach to Abuja, when your durability factor is what the consultant or what the designer of the structure talked about, and you achieve it as concreting. All right. So yes, this is what I was just mentioning a few minutes ago. Water reducers, or otherwise known as plasticizer, are classified as low range, mid range, and high range. So plasticizer, so we have the low range of 5, and that's mostly type D. You have the mid range of 8 to 15. Okay. And here we talk 1 to 2 inches. I don't see the relevance. Actually, this is a mistake. I should remove this. So please just forget about the 1 and 2 inches. Okay. And the 4 and 5 inches, and the 8 and the 8 and 11 inches. These are irrelevant. I'm sorry, they are here by mistake. Okay, so low range, yes, 5%, mid range by 8%, and high range is 12%. Okay, 40%. It can be up to that. Yes, and high range of SNF, as I said, different types of admixtures is just like from 20 to 30 liters of water per liter of admixture. However, for PCP product, which stands for polycarboxylate admixtures or polycarboxylate ether admixtures, okay, it can go up to 40, and there is sometimes even higher, which is like 50. Okay, retarding admixtures work slowing the rate of setting of concrete by slowing the initial setting time. The concrete mixture can stay in the fresh mix state longer before it gets to its hardened form. Okay, so well, this is fairly said, and yes, retarding admixture actually what it does. Different types of retarders there is. Okay, but however. Some of them they work on disperse the particle of cement and taking it to the surface. Okay, so they actually prevent the reaction of cement, okay, with water. All right. So also the timing of even adding admixture to the mix is very important. All right. So when to add it? Is it in the beginning before we add the addition of water? How much percentage of water should I add until I add the admixture? Okay, what is the best time for it? Okay, and here it goes. If you have an SNF admixture, okay, it's better to add your full admixture after 80% of your water addition. 80% of your water addition, you add your admixture. And if you had a PCP admixture to be used, it's preferred after 10%, 10% of water addition to your mix. You add the admixture, then you continue with water to the 100%. All right. All right. So uses type B retarding admixtures. Okay, long transporting. I mean, all of us know what is the retarder for. Okay, we want to transport our something else. I'm sorry, let me go back to this. Here, retarding admixture working at slow rate of setting time by slowing the initial setting. Actually, it doesn't slow it down. What happens? It shifts the setting time. So for instance, if you are using water, not an admixture which has retarder, let's say, or not let's say, this is how it is. It's 3 hours, okay, where your concrete will start to sit. If you are using admixture, okay, it will shift it maybe up to 6 hours. So your final sitting time will be at 6 hours, and when you use admixtures, it's gonna be like 9 hours. So water 3 to 6 hours initial final sitting, admixtures 6 to 9 hours. So the sitting time has been shifted. All right. Now remember, let me go back here. All right. Now this is when we use the type B of admixtures and we use type G of admixtures. Okay. Type D and type G of admixtures will retard your concrete, will shift the initial sitting time, okay, and it depends on which type of admixture you're using and what's the percentage of admixture you're using. Now, type A of admixtures and type F of admixtures will not shift your sitting time, will not. It's just like you have added water. It's just like your control mix. No retardation whatsoever, okay? No retardation whatsoever. So I want you to remember this. Type A and type F will not shift the sitting time of your concretes, while type D and type G it will. All right. Okay. When we use the type D and type G admixtures, which has retarders, okay, when it's required. I mean, all of us engineers and we understand what's the meaning of that, you know. But some of it is not only because I want to place my concrete, or I want to transport my concrete, or I want to have a smooth surface concrete, you know, or I want to reduce the cost from having problems of my concrete. No, some of it is because I want to reduce the heat of hydration of my concrete because I'm using a lot of concreting. All right, so that's something also to look at. Okay, accelerated admixtures, and this is a part that I would like to talk about, but I don't want to spend a lot of time about it. So accelerated admixtures are used for quickening sitting time of concrete, provides high early strength development in freshly cast concrete. These admixtures are suitable for concreting in winter conditions during an emergency repairing work in case of early removal of formwork. Okay, now I want you please to look at the uses here. Let me read them again. Winter conditions, emergency repairing work, or removal of formwork. I mean, all of it emergencies. Everybody calls me, they want an accelerating admixture. I don't know why. Why do you want an accelerating admixture? Yes, it gives you an early strength. But you know what in concreting? If you get it in the beginning, you lose it at the end. If you get it in the beginning, you will lose it at the end. The best concrete is the concrete that hydrates slow. Okay, get you the compressive strength in a gradual way. Okay, until a few weeks pass, then you'll have your best compressive strength of concrete. The ones that you accelerate, yes, you'll have early compressive strength in the beginning. Okay, but actually at the after, for instance, 28 days or 56 days or 91 days, okay, it will not be like the other concrete which has been mixed with type G admixture, for instance. So let me just give you an example, just to be clear. Okay, so if you use type C admixture to accelerate, and type F admixture, which is just like water without retardation, and type G admixture, which is a super plasticizer. And let's say that the three of them will reduce the water cement ratio in the same level. Okay, so type C will give you an early strength. However, it will give you a modest final strength. You'll achieve it. You see, don't worry. I mean, we can work on it. Okay, but it will be modest. Type F, there'll be no retardation. It will be a moderate early compressive strength, and also an acceptable later strength. Type G, it will be slow in the beginning, still acceptable early compressive strength, but the best reading you will get from type G, you know. And here actually it just crosses my mind to talk about Why 7 days and 28 days? I mean, all of us as engineers and consultants and architectures, we concentrate on my concrete has to be crushed in my cubes, I mean, in 7 days, and the final reading for my concrete is 28 days. Okay. Now, why we it has been chosen 7 days? And how about 30? 30, I look at it as a number is better than 28. It's a round number, even one. So why 28? Why not 30? Why 7 days, not 10 days? All right. And actually, these are contractual. It has nothing to do with concrete. It has nothing to do with reaction of concrete. It has nothing to do with chemicals. It has nothing to do with anything else than payment and contractual reasons between the supplier and the client. I mean, I supplied my concrete and I want to get paid. So when are you going to pay me? So the standard, and since it's called the ASTM, so it's the American standard, and since they are getting paid on weekly basis, so simply 7 days has been introduced. So they say, for instance, that if my compressive strength or my readings for my cube crushings has it's on 65%, you say, then I pass, and I'm entitled to get paid. You say, I'm entitled to get paid. That's the meaning of it, all right? So from where the 28 days came by? Well, in Europe, they don't get paid in a weekly basis. Basically, it's on a monthly basis, and if and the month is 4 weeks, so 7 cross 4, and you get your 28 days. As you can see, crazy, huh? Nothing has to do with concreting. I mean, anybody says that the concrete or the cement or whatever, no, has nothing to do with it. And when we use mineral admixtures, you cannot even test your concrete 28 days. Your concrete has to be tested on 91 days. Okay. If you use fly ash, it has to be 56 days because you will not get accurate readings. Okay. So very important, guys, to know why the 7 and 28 days. And concrete will not become flat after 28 days. It won't. Actually, it will not even after a year. It will keep on progressing. I mean, you keep on gaining compressive strength. And anybody does that, please call me. I have the tests for it. I have tested concrete for 2 years. I mean, cubes, I have made that. All right. All right. So makes concrete faster, promotes strength. Yes. So what's the point then of using my type C? My type C is when there is a reason. I have a reason to use the C admixture, I will use it. However, here in Nigeria, mostly it's hot weather in concreting. So using type C actually will promote cracks, shrinkage, curling, you know, and a lot of problems like plastic shrinkage cracks. So please just do not look at the name of it and you think it will do miracles. No, ask. Okay. Other types, type D, water reducing retardant admixture, I talked about it. Type E, that's the one I said. Well, type E, as I said, is a mixture of A and C, which water reducing and accelerated admixtures reduces the quantity of mixing water required to produce concrete of given consistency and accelerates the setting and early strength development of concretes. Okay, I talked about it. Type F, I talked about type F2, but it's good to read about it too. It's water reducing, high range admixture. Admixture reduces the quantity of mixing water required to produce of a given consistency by 12%. Well, that's statistics, but actually it can even go more and beyond that. Type G, retarding, transporting, placing, lowering the initial hydration of initial hydration temperature of the concrete mixes. And I think type G is the best admixture to be used in a normal situation. Okay. Type F and G, super plasticizers, high range water reducers. These are second generations. Yes, I forgot to mention that. Type D is the first generation. Okay. Type F and G, they are the second generation. PCP are the polycarboxylate are the third generation, and now we have the fourth generation. Okay, which different polymer of PCPs. Okay, as I mentioned else when I was talking about SNF, it's sulfonated naphthalene. So it's a synthetic product, okay, chemically made from organic or naphtalated sulfonates. Okay, application in a very heavy reinforcement sections. Any section which has reinforcement, okay, use admixtures. Okay, if you do not use okay, I want to talk about this. I have been in sessions with some engineers and architects that they say there is no need to use admixtures. Okay, no need. How crazy is that? I mean, I'm sorry, but that's crazy. I mean, admixtures for concrete is just like the soul for a human being. Can you live without your soul? That's the same thing for the concrete. You mix your concrete without admixture means that you will not achieve durability. You will not. Trust me on this. You will not achieve it. As much as you are smart, as much as you're experienced, as much as you're going to talk to me about it, okay? You will not achieve the durability factor that you are aiming at unless your compressive strength that you're looking at is between 10 and 15. I mean, good luck with that. All right. So workability, flowability, there will be room for questions after presentation. Yes, definitely. Workability, flowability, high strength. Yes, this is what you get when you use admixtures. I provide, yeah, and there's a word here which should be also durability. Use workability, flowability, high strength, and durability. Okay, provide the concrete resistance to freeze and thaw cycles. I talked about it. Okay, benefits: improve resistance of concrete to several frost action, freeze, thaw cycles, high resistance to cycles of wet and drying. That's also very important as we are in Lagos. You remember some concretes are in the effect of shore and tie, and this is the worst effect on the concretes. High degree of workability, high degree of durability. Sorry. Yes, miscellaneous types of admixtures. We have corrosion inhibiting admixtures. I think I'm on again. Reclaim host. Shall I reclaim host? Yeah. All right. Share. I'm sorry, guys. You can hear me still? Hello?
Yes, we're hearing
Guys,
you. We're hearing you. The slides are
Okay,
not
I'm
showing
sorry.
very well.
The network just went down. So anyway, so I was talking about waterproofing admixtures. That's the last thing I was talking about. I don't know how much you heard of me talking about it, but I will repeat a little bit of it. So I was saying, please, in your foundation, undergrid, any concrete you use undergrid, use waterproofing, whatever. I mean, admixtures will be the best thing to use. Okay, water repellents and crystalline. Okay, and if you want to use the sheets of SBS membranes, it will be great. All right, but you have to add waterproofing admixtures to your concrete. You have to. All right, or waterproof your concrete itself. I mean, if you don't want to use the admixture, it's fine as waterproofing, but you have to use a concrete admixture to reduce your water cement ratio. This is a must. Okay. Now, if you don't want to use the first one, you don't want to you don't want to use the second one. Well, you have God. I can't tell you more than that. Okay. Then good luck, as we call it. All right. Remember, so many problems avoided if we use the right solutions from the beginning. If not, the treatment of it is going to be like 1,000 times more expensive. Now, this is if we can treat it originally, and
Yeah.
some of it that I mean, you'll pay this much, and still the what action we're going to perform will not be guaranteeing that this problem is being solved. You know, it's very important to waterproof the foundation of any structure that you are going for. Very important. I stress on this 100 times. Right. So in Costar here, we have the SNF admixtures, which is in the category of 200. Costa mix 200, 200R, M is the type F, MH is type G, RX type G, DG is the strongest that we have. It's also type G. Okay, PCE admixtures, it's polycarboxylate ethers. Okay, and they are in the category of 300, 600, 600 DG, and we have the 700, 800 now. Special admixtures that we are talking about, corrosion inhibitors, air and training admixtures, accelerating admixtures, all of this also as type C, CR, AW, air, 200 casts, and the accelerated admixtures. Costar lightweight or lightcrete, block 10, 20. This is for mortars, and also we have concrete dissolvers. Okay, what's the concrete dissolvers? That it will, if what you call it, soften the concrete, but it will not melt it like you put butter on fire. No, it will not happen. You know, it will soften the concrete, but it will not dissolve it like sugar in water. No, it's not. All right. So this is our range as Costar. So we have Costar 100, 200M. These are type F products. The 200R and 200 are type D and G. 2R,
Please,
200R.
please, can you share your?
Can I share? Sorry.
We can't see your slides. Can you share your slides,
Yes,
please?
yes, 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 yes. I'm sorry. I'm sorry. Let me just see why it's not being shared. 1 second. Disable sharing. You have disabled me on that. No, it's not working. Okay, so now I can share. Wait a minute, guys. Windows. No, it's not happening. 1 second, guys. 1 second, please. I'm sorry, guys. I think we are online again.
No problem, sir. Thank you.
No issues. So let me just go fast because I had to reset everything from the beginning. So where were we? Tab D, F, G, miscellaneous. This is an F admixtures. I was talking about the categories of admixtures. I talked about the importance of using waterproofing admixtures, target markets. Yes, construction companies, architects, consultants, development. It's that target market. It's the people that they should use. They should invest. They should. I mean, as I mentioned earlier, admixtures are without it you cannot achieve the concrete properties that you're looking at. And anybody says is that, I'm sorry. I don't know what to say. Concrete admixtures does not only improve workability, strength of concrete. No, it does not. Okay, it is the one that will enable you to have durable concrete. It saves stress, time, and costs. All right, I know about time. I'm sorry. And thank you. Now, before I say thank you, there's something else that I want to add before I say thank you. Curing of concrete. Curing of concrete. Concrete is very important to be cured. So if you cast your concrete and you done it in every perfect way that I talked about and use admixtures and you did not cure your concrete by water for 7 days, 3 times a day, you lose 50% of your compressive strength and you lose your durability factor. As simple as that. So if you cannot cure your concrete 3 times a day for 7 days, then use curing compounds. Okay. The most important thing that we avoid water going out from the concrete with no escalated reason. I mean, the evaporation of the water and the water progressing from under, this should be on a certain rate. If not, cracks will happen, shrinkage will happen, and yes, I mean the durability factor of your concrete will be lost. Remember, curing equals 50% of the strength of your concrete, and if it equals 50% of your compressive strength means it equals more than 50% of your durability factor. There's a lot I want to talk to you about, guys, but I think the time will not help me. There was another slide that I wanted to go for before I say thank you, but I don't think that we have the time. We don't have. Do we have that time on there? Do we have the time? We don't. Right. So I would like to thank you. I think that I'm done for the day. So if you have any questions, please go ahead.
Thank you very much, Professor.
Thank you very much, Hassan. That was a very lovely presentation. Thank you.
I'm sorry,
all
I
our
took a long time.
participants.
I mean,
Yeah,
I'm
you did,
supposed to
but
60 minutes, but I took more than 60 minutes.
yes,
So
but it's
apologies.
still okay. We understand that the network was failing sometimes, so it's all right. Please, if you have any question, please raise up your hand so we can ask you to unmute and present your question. There are some questions in the group chat also, which I'm sure
Yes,
Hassan has
I
seen.
can read it to you. Does water reducing and admixtures have any disadvantage? Will, if it's as a water reducing admixture, I mean, as type A and DEF, I would say none. No effect whatsoever. As retarder, yes, it does. If you go more than the required percentages. Of course, I mean that if you open the internet and you put the disadvantages of admixtures, I mean there'll be a lot of stuff they're talking about disadvantages. But what I'm telling you is the fair middle truth of people who tested admixtures for a very long time, and I have worked with a lot of people on different types of admixtures. Okay, so if we are talking about type F admixtures, it has only good advantages in the concrete. Type G admixtures, yes, it does. However, you have to be careful when you're using it, not to exceed the dosage, because if you do, your concrete will not cure in 24 hours, which means air will be infiltrated inside your concrete, and yes, you will achieve compressive strength. However, your durability factor will be affected dramatically. Now, using accelerators also in the wrong time and the wrong type of application, it's really just like using medicine for the wrong type of the diagnosis. I mean, you have a headache and you take a medicine for heart problem, or yes, and what I'm trying to say, what I'm trying to say is admixture is not like a new technology. It's not. It has been used 7,000 years ago. You can see the posts and the coliseums of the Romans, right? Remember, without admixtures, it won't be here. Okay, I mean also the pyramids of the pharaohs. It also some of it has been made of stone. Some of it is concreting, by the way. Maybe a lot they don't know this, but this is something that is worth to be mentioned. I hope I have answered the question. Okay, there's another question. How do you manage cold joints? It's a long story, but what I would say, try to cast your concrete one go. Try to cast it one go. Now, if you cannot, then you have to have a controlled joint. I mean, before you cast concrete, you should plan it, and you should add something called water stop on that area. So you stop where the water stop is. Okay. Now, if something dramatic happens, and you did not use water stop, and it's unanticipated, it was I mean forced that you have to stop, and you had a cold joint. Now, if it's for like 1 hour until your concrete reach the site, so you can agitate the side of the concrete, not to let it go to sitting until your concrete reaches. Now, if there's no concrete, I mean, that's it, you're gonna stop. Then try to finish your concrete in an elevated, in a way like 45 degrees shape. Okay, so next time when you want to resume concreting, we can, and you did not put water stop, we can put something, we call it water rebar in that place, and also we can use some kind of bonding agents. All right, and there's different types of bonding agents. I prefer to use the SPR one, okay, in that area. But still, versus, I mean, try not to have a cold joint from the beginning. Remember, it's a weakness. Any questions else, please? Okay. What type of admixture is recommended for concrete works where the formwork is completely or partially submerged in water? All right. This is actually not only admixtures. It's so the question is, again, let me repeat it. Recommended for admixtures, recommended for concrete works where the formwork is completely or partially submerged in water. Okay, so that's this different types of concreting, and we call it underwater concreting. Okay, and you might be surprised, guys. It's nothing much else than the normal concrete, but we use different mixed design. We use different mineral admixtures. So we use sometimes silica fume, and we use anti-wash admixtures. This is the type of admixture if you are asking about it. We increase the viscosity of the mixture by using viscosity modifiers as admixtures. Okay, and there is also some kind of net that we use it in the different. I mean, how deep and what type of water is, if there is a current or something, we don't want our concrete to be washed away, you know. So yes, there is different types of admixtures, and we have it. All right. I have answered your question. Okay. What any other question? Explain. Yes, wait a minute. Explain again the relationship between water cement ratio and durability. Yes, water cement ratio and durability. The more you drop your water cement ratio, the better your durability will be. Do not drop it to the extent that there's not enough water for your cement to react. Remember, the minimum water cement ratio you can go for is an average of 0.23. You cannot go beyond 0.23, whatever happens, unless okay, there is a way, but I mean, I don't talk about it now. All right. So water cement ratio and concrete and durability. So I said, if you let me remember. Okay. So what I said at that time, if you drop the water cement ratio from 0.5, 0.4. So the capillary system of your concrete will be dropped 1,000,000 times, not 1,000,000 volts, 1,000,000 times. And if you want to calculate on statistics, if you drop your water cement ratio from 0.5 to 0.4, that's only 1 point. I mean 0.1%. Okay, this will increase the durability factor and the life expectancy of your structure from 28 years to 163. So I'm repeating this again. I hope this is what else. Okay. If other questions, how do you measure durability? We use durability. There is standards for it for measuring durability, and there is tests for it. And actually, we own it here in Costarchem. We have the machine for it, and we can even tell you for how long is your reinforcement is going to live without corrosion. We can tell you the life expectancy of your structure. Okay, and all of that depends on the impermeability of your concrete. So all our tests actually depends on how permeable is your concrete. So that's how it is a durability, impermeability, and your concrete being penetrated by the surroundings like water, gases, whatsoever. Right? Thank you for the presentation, sir. Please what grade of concrete and admixture can be used for piling activities, especially when transported for distance. Grade of concrete and admixture can be used for piling. Well, it depends on what is the design of your pile.
Right.
So most of the piles are being designed as C40 and C45. And how far they are, well, it depends also on the distance of it. But mostly it's going to be type G if you want to use it.
Hello.
Hello, Hassan, are you still there?
Hello.
I want to believe it's network issue. You'll be back.
Yes, I think I'm online again. Yes, I'm online again. So I was thinking there's companies, they really put a lot of effort and investment on a good mixture for their piling system, concrete mixture, I mean. But when the truck reaches the site, I mean, for the reason that the concrete started to harden or they have lost, not harden, but they lost the slump and they cannot cast it, they add water. Remember, you can recalibrate your concrete admixture. Remember, we have talked about admixtures type A and type F. And as I mentioned it will not shift the stick time. All what you have to do is to add this admixture with a certain dosage that we can walk you with it. All right? And nothing will happen. If you start your slump with 200, and after 2 hours it gets dropped to 20. I mean, who can cast concrete with 20? No one. So shall we throw the concrete? No, we should not. Shall we add water in it? Definitely not. Throw it better. All right. So what should we do? So you can add type F admixture, in our case called Costa Mix 200 m or Costa Mix 200 ms. Okay, you will again get the slump of 200, and your concrete will become workable again. You can cast your concrete to the intended place you want to cast it to. Remember, you don't have much time when you add the type F admixture. You'll have like between 20 to 30 minutes. That's about it. Okay. And by the way, you can add it twice. So the first time, I mean, if the first time also you needed, it was not enough, you can add it a second time, but not more than that. And it should be 30%, the first time should be 40% of the first addition. And the second time to be 30% of the first addition. So let me just for saying numbers. If you added in the beginning 10 liters of admixture, you mix water in the beginning, so you can add or you can calibrate your mixed concrete by 4 liters of type F admixture. Okay, the second time it would be by 3. All right. I hope I answered the question. What else? What type admixture recommended for concrete works from partially submerged water? I said that type admixtures recommended for concretes completely okay. According to the speaker, concrete do not make 28 days. Does this mean that concrete strength gain is forever continuous? Is gain is forever continuous? Does this means that concrete strength gain is forever continuous with curing? Yes, that's a good question actually. Yes, concrete will not stop in 28 days, will not stop in 6 months, will not stop in 2 years. As long as there's cement and there's moisture, it will continue on growing and continue on gaining strength. I remember a building in Texas. Is it Texas or Oklahoma? I forgot. However, it was 53 years old, and when they took a core system from it, they found like around 50% of the fly ash, and it was not reacted yet. And they said if there was water that could react with cement to produce the free hydroxides for the fly ash to continue reaction, we would have had more strength even after 50 years. However, I wouldn't say it will not flat. It will, you know, but not in 28 days. Not in the first at least 2 years. Concrete will keep on growing. Remember, there is no definite time for it. I mean, why do we like to put, you know, definite things into things that we don't know? I mean, we do not control. You know, there is no need to say this concrete is a flat line after it. Well, it's not. Okay, it's not. Remember, 7 days, 28 days. It's for contractual reasons. Has nothing to do with anything called reaction or chemical reaction of cement and water or different types of admixtures and the cement. Has nothing to do with it. And I will repeat myself again. Yes, as long as there is cement, and yes, as long as there is water. Okay, not only the ordinary cement that we are using, okay, which is the Portland cement. Okay, no, it's not. Different types of cementitious products. The concrete will keep on growing in strength. Yes. All right. So, what else? What do you mean? How do you measure durability? We talked about that. Thank you for your presentation. Please, we can use finding activities. If there's a can let us achieve before mature date. Yes. Let me see again here. Is there admixture that can let achieve the strength of concrete before mature date? Yes, there is. But what I'm trying to say, if you want your concrete to get matured, I don't know what's the meaning of maturity here. What do you mean by maturity? Is it the specified compressive strength? I mean, if the consultant specified your concrete to be 30 MPa in 28 days, do you want it to be in a week? Yes. However, nothing goes without cost. We can design your concrete to be 40, you know, and you achieve it in a week. I mean, you get 30 in a week. No worries about it, but you have to pay more money for it. Remember, the ultimate strength of it will not be 30. If you measure it after 6 months, you'll be surprised. Actually, you'll be shocked. Okay, it will not be 30. I mean, 28 days. It will, I mean, I would like you to try it. You know, many of you have companies. Many of you do cast concrete on a daily basis. You have cubes. Try it. I mean, cast some cubes. Okay, instead of making 6, make it 20. All right, submerge it in water and leave it there. Every and 28 days, break few. Okay, in 2 months, break a few. In 6 months, break few. In 1 year, if God gives us life, I mean, break few, and check out the results. You will be really surprised. All right. For future questions, they should fill the feedback form on the chat box. Okay, I have a message here for you guys. Please, for the questions, please fill the feedback form on the chat box, and we'll get back to you. All right, that's because I think our time is done, right? So I'm sorry for if I didn't answer any more questions, but I'm here at Costar. My details, I think it's recognized. And if you need me for any other consultation, I'm at your service. I do thank you very much for your time, and hopefully until we see you again.
Thank you, Azan. Some hands are actually still raised up. If you can take those 2 hands, then we can let you go afterwards. Yes.
No issues. Please go ahead. So
thank you. Engineer Bebefe, can you unmute yourself and give us your question, and afterwards, Engineer Quadri. Thank you.
Good evening, everybody.
Good evening, sir.
So I was actually trying to follow your presentation, but at a point in time, I couldn't get what you said regarding adding admixture when you are doing casting on site. At what point do you add admixture? When you are doing casting on site, at what point do you add the admixture? You were mentioning it in the presentation.
Yes, I understand. Now, first of all, let me ask you these 2 questions: are you mixing it in a manual way or mixing it in a transit mixer or a batch plant?
No, not in Bashman. We have a mixer on site.
Mixer, I mean manual mixer, right?
Yes.
0.5 cubic meter or 1 cubic meter per mixer?
0.5.
Per mix. 0.5. So actually, this is half a cubic meter, all right? And let me ask another question. So when you mix it, how much time it will require you to transport your concrete from your mixer to the element that you are casting the concrete in?
Within 2 minutes. 2
minutes. That, I mean, that's instant. So I would recommend that you use type F admixture. Okay, the type F admixture. I mean, the one with no retardation. Okay, and since we are using the type F admixture, so you add the admixture after the addition of 80% of water. All right, after the now you are using manual mixing. Okay, so in this case, because you are using manual mixing, you will not be able to control exactly when to mix the water. You know, so in this case, we will say add the admixture to the water itself. Okay, so since it's 0.5 cubic meter, and you have, let me say that you are how many bags of cement you are putting?
That's going to be 25 kg. 25.
Half a bag.
Half a bag.
Half a bag. So I mean, proportioning everything will be half a bag is not half a cubic meter, man. You see,
yes, I know. Have a bag.
Have a bag per mix. You know, we are talking about a very small mixer. Yes. I mean, if you talk about half a cubic meter, and let's say your cubic meter have like 400 kilograms of cement, so it should be at least for 200 kilograms of cement, which means 4 bags. All right. Anyway, what I'm trying to say is this: add your admixture to the water, add it just after you start mixing your components, the aggregate and everything. Add the water, add admixture to it afterwards, and that's about it. Mix properly, please. Mix it properly. Okay. Mix it properly, and remember, your slump should not be less than 180. I mean, remember, any slump which is less than 150 is not good for you. It's gonna promote problems. Something else, please. Mix waterproofing admixtures if you are going for foundation. All right, it will cost you nothing compared to what's gonna cost you in the future. I hope I answered you.
Okay, thank you very much.
You're welcome, sir.
Hello. Hello.
Yes, go ahead.
Hello. Hello, can you hear me?
Yes.
Can you hear me?
We can hear you. Yes, go ahead.
Good evening, sir. Thank you for a wonderful presentation. Actually, I have 2 questions. The first question is how cost effective is the use of these admixtures? For example, if I want to use admixture for like a 1 cubic meter of concrete, I just want to know the cost effectiveness of using admixtures on site, and that's the first question. And the second one is it advisable to use admixture on reinforced concrete, and does it actually have any effect on steel? Maybe does it cause corrosiveness in steel? Yes, those are the 2 questions. How durable is using admixtures in reinforced concrete, and cost implication? That's the 2 questions. Thank you.
We can't hear you. You're muted.
Hello.
You're muted, Hassan.
Hello, can you hear me now?
No, it's not you. Hassan is muted.
Okay.
I'm sorry. It was my mistake. All right. I don't know, or maybe Monday muted me. He likes to do that. I don't know why. Anyway. The second question, first question, I got it very well. The second question, actually, I did not understand it. You said, can we add admixture to the reinforced concrete?
Yes. Can it be used?
Does the admixture corrode the reinforcement? Does it have a side effect on the reinforcement?
Yes. I understand. I understand the question. All right. Sir, let me start by the second question, since it's the easiest one to answer. Okay, concrete is an alkaline, and the more alkaline the concrete is, the better for it. However, the more alkalinity of it, we have something we call it carbonic acid, if you heard of it.
Hello, I can't hear you.
Okay. I'm
Hello.
gonna get. So it is the one that's gonna protect your reinforcement and your steel in your concrete from the corrosion. The admixture will. I mean, we have a type for it. We call it corrosion inhibitor. All right. And when you use the admixtures, you reduce the water cement ratio and you reduce the voids inside your capillary system. And for the water not to penetrate, which means you increase your impermeability. So you decrease the permeability of your concrete. All right. So which means that your reinforcement is more safe. So yes, admixtures has only good news for you. There's zero news if you are talking corrosion. All right. That's what you're talking about, normal types of admixtures. Okay. It's other types of admixtures I don't like to talk about in this session because it's irrelevant. Now, the first question, which is cost. How direct is the cost? How direct is the efficiency of using admixture or our cost? It's 100%, sir. I'll give you an example. In your mix design, if you have 380 kilograms of cement to be used for C30 of concrete, if you can achieve that with 300, that's 80 kilograms of cement. Okay, that's more than a bag of cement. So if the admixture per liter is 400 or 500 or even 1,000 naira per liter, okay, the bag of cement is 5,000 naira per liter, per bag. Okay, so if I can reduce your cement content by 50 to 80 kilograms, okay, by using admixtures, this is saving costs or not? It's not only that. You will have better strength concrete, you have better durable concrete, you have better placed concrete that will be transported, placed, and minimum vibration, which means more homogeneous. When you move your formwork, you'll have smoother concrete, which means you don't need to use concrete okay, or your concrete will have the same color, no discoloration, okay. So it will be even better for the eye to look at, and people, they will even feel safe when they come to see your structure and or inspect your structure. All right, I hope I would have answered your question.
Yes.
Thank you, Hassan.
Right.
Thank you so much. Victor, you have something to ask? That's the final question for today. There's a feedback on the chat box that says you can put your questions in there and Hassan will get back to us. But Victor, please go ahead and ask your question. And that's all.
Go ahead,
for
Mr. Victor.
Okay, good evening, everyone.
Good evening to you, sir.
Yeah, there's this mix that was done on site, grade 25. And
Yes.
We added an admixture from your company. But,
yes,
you know, I need to ask something, you know, in this part of the world.
Yes.
I don't know, maybe your admixture, the weather in our country is being considered before you produce your admixture. I don't know that. One.
So,
Then two,
sorry again, I don't get that. Can you repeat it?
You know, the weather of this country is a little bit different from other countries.
Yes.
And I believe it influences the your mix ratio too, especially when you have this hot weather that we are experiencing now.
Yes. All
So
right. So what's the question,
now,
sir?
now we did a mixture, which was, you know, there are different types of manual. If I can get it right, it's not by machine. We can mix on guns. Sometimes we mix on guns too. We don't use machine.
Yes.
You get artisans, you give them your mystery shoe that, okay, fine. Give me like by weight, a bucket. That is that paint bucket of cement.
That's
One.
25.
Give me 1.5 of sharp sand and 3 of granite to make sure your grade that you want to achieve. Now, 2 cubes was taken from these mixtures, and we had an admixture with water.
Yes.
We had an admixture with water. So 2 cubes was taken from this sample. When the crushing was done after 14 days,
yes,
one gave 26.3 kilonewton per millimeter cube. The other one gave 10.
Expected. All right.
The second one gave 10. If I was not there, I will argue it out.
All right.
I will argue it
All
out.
right.
Yeah.
All right.
But let me tell you, the amazing thing is it was for a pie cap.
No. That's
You know,
really
it was
serious.
a pie cap. Yeah, it was a
I'm
pie
sorry,
cap.
sir. I'm sorry to hear this. I hope that you didn't have a bad time.
No. See, when we did the PLT, as I'm talking to you, the PLT passed well. The PLT was good. It was good. But what I want to ask is, what can cause this kind of thing when you have a difference in the result of that kind of test cube?
I got it.
What can cause it? Yeah.
All right. First of all, I would like to comment on what you have said, that Nigeria is the weather here is different and the circumstances is different, and it's true. Okay, but for me, this is the 14th country. Okay, so I have served in countries where the temperatures are even double what's here in Nigeria. I mean, in Nigeria, sometimes it goes to 32 Celsius centigrades, and I've seen temperatures in Kuwait which is 65. Yeah. In the shade, it was 58. I mean, I wish nobody be there. All right, and also in Canada, it's minus 40. So different types of the world, different types of admixtures. However, the types that we are using here, okay, it's commonly the normal types, which is the type from type D and type G and type F. I mean, these are normal types which being used all over the world. I mean, being used in Europe, being used in the moderate temperatures. I mean, if your temperature is between 10 Celsius centigrade and 35 Celsius centigrade, these are the temperatures that we are using here, and there is nothing fancy about it. I mean, in Jordan, in Syria, in Lebanon, in Turkey, and in Germany, if the temperature is between 10 and 25, you see, we are using the same type, or 35, we are using the same types of admixtures. All right. So that's the first question. Now, the second thing is for why is the consistency in results doesn't happen. Okay, so actually, your question reminded me of something very important I have to talk about. So if you guys are still here and following me, please write down this type of this specification, which is C172. CASTM C172 talks about the sampling and testing of freshly mixed concrete. All right, there's a lot about how to take the sample of the concrete. All right, so sampling of the concrete has to be taken not from the first 10% and not from the last 10% of the mix. It has to be taken from the middle of the mix. It has to be taken in 2 times. All right, it has to be mixed together. Then after that has to be placed in the cubes according to STM also. It should be placed in 3 proportioning. If each proportion has to be hammered with 36 strikes. all right, then finished with a smooth surface. Okay, the cube should be opened after the concrete gets hardened, and the cube should be placed in water in temperatures between 10 and not exceeding 21 Celsius centigrade. That's how the thing is being done. If you didn't do it this way, well, each mistake has consequences on the consistency of your results. I'll give you an example. If you strike the cube with, I mean, the rod, the hammer should be 1 inch by 1 inch. But if you go, or if you take a steel bar of 16 mm and you measure them, you'll find that they have the same surface area, but they don't. If you do the hammering with the specified one, and you do another cube with the rod one, okay, you are minus 16% on the compressive strength. That's straightforward. If two guys do different types of cubes, you are minus 21%. I mean, anything you don't do it according to spec, the testing of concrete is about conformity and about consistency of doing the steps of it, okay, and how you take the sampling of the concrete, okay. So and that's about it. If you don't expect your results to be the same. That's the first part of it. The second part of it, it might be that your mixing was not homogeneous. You see, your mixing is not homogeneous at all, okay, or something external than the cube when it still was not formed well. Somebody touched it, or somebody hit it, or got hammered on the ground, or you understand me. There's many things that can happen, all right, but it cannot be that one cube gets you 26 and the other gets you 10. What I had, in experience, I've seen cubes they go backwards. You see, but I mean, at 7 days I get high strength, but on 28 days I will.
We can't hear me again. Is it from my end here?
I'm back again, I think. Hello? Hello, I'm back again.
Welcome back, Hassan. Welcome back.
Okay, so I hope I answered your question, sir.
Yes, you have.
All right, and please, for any further thing, just give me a call. I'll come to your site and see what's happening.
Did you call Yaro?
Okay,
thank you very much, Hassan. Thank you for all the elders on the platform. We say thank you. We'll get across to you.
I'm looking forward to see you again.
You could not share your contact, but it's all right. I wanted to also share a certificate of appreciation, thanking you for this wonderful lecture. Maybe I'll bring a hard copy to your office.
Well, I think everybody have the company's phone number, and if they have, they can reach me. There is no issues. All right.
Okay, you need to share the company.
And also you can fill the form that we have it. Also we will contact you. There's no issues.
Okay, please fill the feedback form to get across to Azan. Thank you. Thank you. We're one time way off this meeting. So we say thank you, everyone. Have a lovely evening. Thank you, Costarchem, Nigeria, Costarchem International. We are grateful for this session. Thank you. All right, we look forward to another session. Thank you, everyone, for logging in. For your questions and answers, we can use the feedback form to get across. You can visit their YouTube page to look at the videos there, to learn one more thing or another. Thank you, and have a nice weekend, everyone. Thank you. Bye.